Okay. Hello, hello. Oh, too loud. Congrats on the first, Joseph. Hey, Scorpra. We've been good. Okay, I think that's a decent volume. We'll find out. Okay. Hey, Rex. Avoid gunfire in the bathroom tonight? I feel like you should be avoiding gunfire in any location, not just the bathroom. But hey, BR Gaming. Um. Okay, so I'm hoping to finish up two different homework assignments. This one is for my math biology class. Um. Ugh. This question was about a predator-prey model, but kind of a cool twist on one. Where the prey grow logistically. They get hunted normally. Oops, I just undid something that I didn't mean. I can do that. And then the predator. What's the predator? Oh yeah, they grow logistically, but with like a variable carrying capacity. It depends on the number of prey, which I think is kind of cool. Permutation combinations do suck. 10 streak, holy crap! Thank you. Hey Vossen. And so we did a certain change of variables just to get rid of most of the parameters because there's kind of a lot of them. And so we end up with the system here. And part E asks us to use this theorem to show that the phase plane has no closed orbits, which basically means like it's called like a center stability, where like you just oscillate around a node and never like go out or in. And this theorem can eliminate that possibility, which I think I already eliminated it, like based on work in prior questions, but we have to, I guess, get practice using this. Um, and so it's basically you choose some function b. I don't know why I had to think about what Greek letter that is. um, you multiply it with each of your like expressions of the system, or like for with each of your differential equations, I guess. And you take the divergence of that, and you have to show it doesn't change sign in the region that you're interested in. So, so this right here is my function f of xy. This right here is my function g. So we have BF and BG, boyfriend and BG's the band, dotted with del. So it's going to be the derivative, partial derivative with respect to x of this function that we're just given, because you have to like just guess what b is, or b could be any function. So thankfully we were my professor gave us this to use, because I didn't realize that she did give us what function to use, and I was trying to figure out for myself, and it was kind of a nightmare. So I'm going to do this times that. Let's actually write this out. So partial with respect to x of x minus, ooh, that's not, yeah, x1 minus x minus y over xy plus partial with respect to y, beta y, love ain't nothing but a heartache. Okay. And then And cancel those x's, cancel those y's. I'll do one more. I was gonna do this all in my head, but I'll do another step written out. This one is beta over x minus beta over alpha x squared. Trying to do those two. I'm missing a y in the bottom, right? Or wait, way on top. Yes, okay. Dora, no, this is the same course. This is for my math biology course. We're doing or this question is about like predator prey models, and we're trying to do like stability analysis on this particular like version of it. And the question at hand is to use a theorem to prove that there's no like stable orbits. And it basically just involves applying this one like theorem and showing that what we get out of this thing isn't going to change sign in the region that we're interested in. Okay, so partial with respect to x of that is minus 1 over y. Partial with respect to y of that is minus beta over alpha x squared. Oh, well, perfect. Because this is always less than 0 when x is greater than 0 and y is greater than 0, which is the region that we're interested in. Okay, so that's actually that question done. The only piece left of this question is to draw a phase plane. And this question, well, it wasn't the most annoying one. Is this Biggie's voice? I think it is. Like way in the background of the song. Oh, well, the music is kind of loud. What the hell? Oh, it's the symbol. It's like that loud. Holy crap. Okay. I did most of this homework off stream, but I'm gonna show the most annoying part of this homework was they asked us to draw the possible phase planes for the system up here, which this one was cool too. This homework time was actually like kind of cool, except for the amount of work they're having us do. And the issue with this system is that there's so many freaking parameters that there's a bajillion cases. So when they say to sketch the possible phase planes, there were 6 different cases for the different behaviors. So I literally like I made this, and yeah. This one, I think we only have 2 cases at least, and they say to draw a typical one, so I could even just take that as permission to do just one. I don't know how to decide which one would be typical, though. So what are the equilibria? We have 1, 0, which is a saddle point. Then we have this one, which has 2 cases. It could be a stable node, it could be a stable focus. Hey, Aditya. we have any indication? So like, when is this quantity? This is only, I think we only get this case if beta is small relatively. Because if beta is large, squaring is going to have a bigger effect than multiplying it by 4. So I'm going to say that the stable node is the typical case. Hey, Roxra. Fundamental theorem calculus now noise. You're zooming through calculus. I think it's asking how to get into a university in the U.S. You're from a foreign country. I mean, I've never had to apply it from outside of America. Yeah, honestly, I'm sorry, but I'm not really sure like what advice to give you. Like, I don't imagine it be that different from applying to any other university, but like, yeah, I'm sorry, but I'm not really sure. Hey, Stefan. So wait, 1-0 is a saddle point. Oh shoot, we should get an idea of how the saddle point looks though. Um, I mean that depends on the university. Aditya, we don't have a standard. Kunal, I'm sorry, but I can't. Okay, so if lambda equals beta, what does the eigenvector look like? Negative, negative, which means it's going to have a positive slope. So it'll be something like that, and beta is positive, so that'll be unstable. If it's -1, that'll be 0. So it'll be a vertical. Is that a vertical line or horizontal line? Why am I confused by this? It's like 0. And sorry, it's Stefan. I see you. I'll just. Want to think about this one thing. Oh, did I misunderstand this? X can be anything. Y has to be 0. No, I don't know. Let me see what Stefan's thing was. Around sine of x? I don't know. I don't know what problem you're talking about. Set 2, third question. So I'm just arranging my windows here. Okay. Because for every n greater than or equal to 2, this relation is true. Zach is shilling physical textbooks. That is very 90s, yeah. The kids shill for Paul's online notes these days. Format it with that. Oh, like Sigma. Yeah. Interesting. Okay, so starting with the base case, Sigma balls. They give us that the base case should be for n equals 2. Which means it looks like 1/2 plus 1/3 plus 1/4 is greater than 1. Is this true? It should be. Hardlocked with the tier 2 for 30 months. Holy crap, dude. Thank you so much. I appreciate you. Learn Big E and Big S, nice. I've been wanting to like get the crew back together for Phasmophobia Hardlocked. I probably like once I'm on break from like school, but just like see what's new. Why can't I do fraction math? A half plus a third is 5/6. Sorry, I know this isn't part that you're asking about, but I just want to do every step here. Uh, 6/24. There we go. 26/24. That is indeed more than 1. There we go. And Jed, that includes you too for the Phasmophobia. Okay. Yeah, at least for the base case, we know it's true. This is a little difficult to write in Sigma notation because the number of things we have here depends on n. Interesting. Oh, wait, no, maybe we don't need to think that hard about it. So yeah, we assume it for some k. The sum from I equals k, I think up to k squared of 1/k. This is how we can write it, is more than 1. Is this accomplishing what I want it to accomplish? Yeah. Okay, so this is Greek letter sigma, capital sigma. Maybe for Frank Johnson. Yeah, 1/I. Thank you. Much better. Well, yeah, so like this is capital sigma and that's lowercase sigma, but like that part isn't super important. It's called summation notation. So yeah, if you know programming, it's like a for loop, and if you don't worry about it. Yeah, this notation is good to oh, you do know. Okay. Yeah, so okay, it's exactly like a for loop. So if you want to write 1 plus 2 plus 3 plus 4 in summation notation, it's like I equals 1 to 4 of I. You do C++? Oh, nice, nice. So yeah, it's exactly just a for loop. Okay. And you could do this problem with avoiding summation notation too. You could also just write it like that with a dot 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 if you really don't like the summation notation. It is good to learn it though. Hey, Skirtle. Okay, so now we want to prove it for k plus 1. Something that you don't like is that, yeah, that's fair. Solve a Rubik's Cube? Okay, we can do that after we get through this question. And I'll say for this question, we probably do want to expand this sum out anyway. I don't think this summation notation is going to be that helpful here. Oh yeah. I'll pause here so you can like read it. I is k. K squared is where you stop. So like, yeah, it's normally just like a number, but here it depends on k. Yes, we are given k is greater than 2. Or like, I guess I maybe should have written that out, but well, okay, yeah, sure. For math, backseating is helpful because I make mistakes a lot of math. So int equals k. No. So I would ignore this part if you were going to think about it like a for loop. If I were to write this out in C++ code, you could do like int sum equals 0 for oh gosh, I'm too used to Python, so I might make a syntax mistake here. Let's just say int, like, let's just do k equals 3 as an example. For int I equals k, I is less than or equal to k squared, I plus plus. Sum plus equals 1 over I. And I'm not gonna, or I do cuddle my braces. And then you could like print like, or like, and the thing that we're claiming is that, I guess we can say if sum is more than 1, you know, success. What's a comment in C++ again? I don't think it's, is it slash slash or dash dash? I don't remember. Maybe it's slash slash. Slash slash, okay. Oh yeah, I miss comment blocks. Python doesn't have comment blocks and I miss it so much. You can do strings, but I think that's stupid and I don't want to do strings. No, I don't like strings. Okay, so awesome. Yeah, it's always great when someone knows programming because it makes it so much easier to explain what this notation means. So for the k plus 1, you could also just figure it out directly from this format here. But if we expand out the summation, it's going to look like this. So we want to get to this thing being more than 1. We're not there yet, though. And we want to use, like, from the assumption here, we know that 1 over k plus 1 over k plus 1 plus 1 over k plus 2 plus dot dot 1 over k squared is more than 1. So I am noticing, I don't know if this is going to actually help us, but this section of the sum is kind of hidden inside this section here. So I could kind of like, if I scoot this off to the side, I know that the term right before this is 1 over k squared. Hey, Milk. Was from the shared except for the first and last? Yeah. Hope you're doing well, Milk. Expand k plus 1 squared? Would that help us, Shed? I'm not sure how. I'm curious to see where this leads. So I could, the only thing that's like, or I guess, Stefan, before I move on, do you see what I'm saying where, like, these two equations have a bunch of terms that are shared? It's only like this one that's out and this one that's out. Okay, cool. So what I want to take the 1 over k and subtract it to the other side. I don't know if this is actually going to help or if this is going to be the way. So what is, if we use this inequality up here, we could replace this with something smaller. So it would be like that is more than 1 minus 1 over k. 1 over k plus 1 squared. I don't know if that's helpful. Oh. Wait. Yes. I think okay. Because we nearly have what we want, which is like this piece here, but we need to deal with like these two remaining terms here, and I think this works. There's no one. Oh, really? No, there is. Well, this term is supposed to be here, Frank. I'm pretty sure. Because I only substituted these things here, so the 1 over k plus 1 squared has to come along for the ride. Compare that. Maybe Jed? You might have another way of doing it too, Jed. I just interested by this. You're saying I'm missing terms? K squared. Oh, shoot! No, wait. I don't... So Frank, you're saying that the summation should end at k squared plus 1? I don't think so. It should end at k plus 1 squared. I assume it's going to be a meme central, but yeah. That was it? Oh, okay. There we go. Oh, Frank. Okay, I see. Thank you, Frank. I see what you... Okay. Yeah, you're right. And actually, Jed was saying that too, and just in a different way. Okay, yeah, so I'm missing things inside here is my issue. That's annoying. Gonna cut up a human body on set. Oh, I thought you meant in DayZ, but like uh, no, I for you're probably gonna actually do it. Yeah, that's crazy. Argue. I could answer any meth question. Please hit me with it. I hope you've been doing good, Hargy. Think about this. Yes, Stefan, this is a tricky induction. Um, so the thing that I messed up is that between k squared and k plus 1 squared, there's a whole bunch of terms that I just chopped off by accident. There's k squared plus 1. And the reason for that is that it's better to think about this like Jed said, like as like k squared plus 2k plus 1. So you keep subtracting 1 off of that. That was for you? It. Okay, so this whole idea might not even work now. Oh, thanks, Stefan. A friend made those names Skirtle. Explain. At FNHC, I wish I knew. The idea that I had is kind of potentially getting thrown out the window right now. Yeah, Frank, that'd be nice if we could use it. I doubt we can though. Okay, so Stefan, how do I say this? There, I was missing numbers between k squared and k plus 1 squared. So like if I mean, I sure hope you get something easier than this. Um, I sure hope it'd be a cadaver. um God, this problem's annoying. Uh oh, I mean, yeah. For group A, that could get a little weird, but 3.5 hour drive to get there is not. Jeez, am I better at math than ChatGPT? I mean, ChatGPT can't do math, so I think like everyone is better at math than ChatGPT. Gonna do things to it. um. Okay, so basically, if I I went straight from one perfect square to another. So like if k was equal to 2, I went straight from 1/4 up to 1/9, and I forgot about the 1/5 and the 1/6 and the 1/7. That's what all these extra terms in the middle are that I just inserted. And that's just a really tricky thing to realize. um and so if we can still use the same thing here to substitute basically this piece out, but then we're left over with this piece. So we need to do, there's going to be another sum involved here. From I equals 1 up to 2k plus 1. And I got that number because this is 1 over k squared plus 2k plus 1. 1 over k squared plus I. Okay, and so I made this summation here because we always have a 1 over k squared, and then it's plus 1, plus 2, plus 3, dot, 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 all the way up to 2k plus 1. Oh, shoot. Quinner, hey. How do you get into artificial intelligence? Seemed logical, didn't have real intelligence. That's not a fortune? Damn, I can't believe my fortune cookie just burned you. That's not cool. Yeah, Central, ask if you can teabag it. S1 and S2 thingies? I don't know what S1 and S2 are. Bow chicka wow wow from it. I mean, it sets the mood, Hargy. I mean, you two always used to appear at the same time. This is keeping it in a great tradition. So with the base case, we could see 1/3 is greater than 1 minus a half minus a fourth. Can we try to build a center term somehow? Maybe? Hey, S-Gain. Hey, Sockno. Same as a coincidence since you hate Central now? That's fair. I mean, Central, you're kind of hateable, though. I hate to say it. Didn't feel like a fortune. you deserve a refund. I can't give you one, Quinner, but you do deserve one. Okay, so we use induction again to show 1 over k squared plus 1. Um. Hmm. Yeah. Milk probably has it. Okay, so Stefan, what we want to do now is we have the greater than 1 piece. We need to deal with this remaining piece here somehow. If we can prove that this is a positive number, which isn't obvious because this is a negative number and that's a positive one. But if we can somehow show that this is a positive number, that means that we can make this next claim that it's more than 1. Because 1 plus a positive number is more than 1. And this is the exact thing that we want for the induction. So inside of the original problem, we're getting like this sub problem that minus 1 over k plus sum I equals 1 to 2k plus 1, 1 over k squared plus I is more than 0. That's what we really want. It sounds good, Harky. Enjoy. Thanks for saying hi. This is supposed to be an iJed. I just have bad handwriting. Bye, Harky. Have a good night. This shit. K is a given. It's the thing we're using for induction. For crystal meth. Oh shoot, Sakana, I missed your message. I'm sorry. In Milk, I saw your message about looking at the form for the sum. Sakano says, still haven't gotten news of where we'll be moving to. It's been 2.5 weeks since they told my family and I that we are moving. I'm sorry, Sakano. That sounds really stressful. I hope that you hear back soon. So yeah, when it comes to like this step up here, it just it's probably better if you play around with it for yourself because it's a little bit hard to explain this, and it's one of those things where you need to like try it for yourself, and I think it makes more sense. Yeah, Jed, you're right. We can get away with or equal to. I hope it wouldn't be too important. We also know k is greater than 2 still. We only care about k is greater than 2 because we already manually showed it for equals to 2. Oh yeah, no, it's not like it's also right to say or equal to 2. It's not wrong. And so yeah, so I can add the minus 1 over k to each side. And this is like a new induction problem here. Frank Johnson is saying, I have an idea. Sum is greater than 1 over n plus n squared minus n over n squared. Oh. Yeah. Suck, now that makes sense. Which sum, Frank Johnson? Like the original sum or like the secondary sum? The original. Basically replace everything after the 1 over n with 1 over n squared. So you're saying keep this one the same. Oh, so you're saying instead of n plus 1, have n squared. Instead of n plus 2, have n squared. And this would be, or this, the original expression is greater than this new expression. But this... Oh, does that directly give us what we want? So hide Aikido. And so we just have to count how many of these terms there are. And so Frank is saying it's n squared minus n. Okay, that makes sense. Wow, that would give us it immediately. What the hell? This isn't even... And I guess you... Well, you don't even need induction for this. Huh. Okay, yeah, so Frank found like a way better way of doing this, I think. This is really hard to spot. And they did specifically say using induction, and I don't think this is induction. But this is a way faster way of doing it. Um, 2n of the 1 over n squared. You only count n minus 1 of them? Because there's n squared many numbers between 1 and n squared, and then we subtract off the n many numbers between 1 and n. It's like 1 over 1 plus 1 over 2 plus 1 over 3 plus dot dot dot. This is n many. This is n squared many. So if we subtract them, we get this chunk. I think n minus 1 seems too simple because one half plus 2 other terms, not 4. When n equals 2, it's 4 minus 2 is 2. Well, yeah, this does work, right? I think it works, Jed. Because it says we have 2 terms, and we do have 2 terms. No worries, Jed. I appreciate you following along. And sorry, Dojo, I see you talking about the number of overlapping terms. Actually, I'm not sure what you mean by overlapping terms, Dojo. I'm sorry about that. N plus 1 terms, from 1 to n is n terms, then the first one. FNHC, I think it's only n, unless I'm misunderstanding what you're saying. Four to 16 plus 3 to 9 minus 3 plus 10 to... Oh gosh. Oh, I'm sorry. I remember you putting the notation in there earlier. From the sum from n to m of the inverse nm. Yeah, I'm sorry. I saw you put that notation, but I didn't understand it. I'm not really sure what that notation is doing. Okay, so and I'm sorry, because there's like there's like a couple of different ways to solve this problem that people are suggesting, and I'm trying to follow along with everyone's ideas, and I physically can't do it. So let me just focus on explaining the way that Frank Johnson suggested. That's really quick. And then we'll go back to trying other ideas. So Stefan, what Frank Johnson is suggesting is just being really clever, and it's hard to spot. But if you can, if you can spot it, I don't think it's that bad. So what Frank Johnson noticed is that we can bound this piece of the sum should I explain this? You notice that this thing is more than 1 over n plus n squared minus n over n squared. And this looks really weird, but I'll explain how he got that in a second. Let me explain like why we even care about this. This comes from a specific thing. But the reason why we even want this in the first place is that if we simplify this, we can split this big fraction up into 2 separate fractions based on the numerator. And simplify these 2 fractions. That becomes 1. That becomes minus 1 over n. These 2 things cancel, so we just get 1. And notice we started with a greater than sign. So what this just showed is if we can justify this step here, which we still have to do, we haven't done that yet, we've proven the exact thing that we want. It's greater than 1. Because we have the greater than sign there and the 1 at the very end. Clonk, when you speak honestly and openly, others truly listen to you. Ooh, that's a great fortune. You can't miss, Clonk. Just get common denominators. That sounds like a lot, but maybe. The project you have in mind now gains momentum. Ooh. Okay, so Stefan, I hope you're with me for like, you know, even if you don't know where this comes from, if you can just like believe that part for now, I hope you're on board with like the rest of this, which is like, if we can just show this inequality here, we're done. Okay. Kowalski analysis. Oh, there. I see what you mean. Yeah, that's true, Jed. Now you're ready? Okay. Okay. So we need to figure out why the heck, so like this one over n stays the same, so we don't really care about it. So why the heck is this thing here a bigger number than this thing here? That is the question. I did Skirtle. Oh, did Jake cut his hair too? um, I actually I've been learning to cut my own hair, and I originally cut it short like a few weeks ago now, and then just yesterday I like tried to give myself a fade, and uh I messed it up, but I didn't mess up as bad as I thought. He just runs a razor through. Oh, that's fair. Why plus then? What plus? I'm not sure what plus you're talking about. Oh, like this plus here. Um. Uh. It gives us the thing that we want, I guess. Like. Well, that's what we're getting to. So like, what we started with is 1 over n plus something. It's and this is the somethings. Like the plus stays the same. We're taking the something and replacing it with a smaller thing. Um. Hey, famished. And so yeah, and so like this is me rewriting the something here. uh and how we got from this side to this side, or how Frank did, is instead of n plus 1 here, just change it into an n squared. Well, I guess, okay, it's not necessarily like just changing it to an n squared. Like if you look only at n plus 1, this is more than 1 over n squared. And we're talking about n greater than or equal to 2. So what we're going to do is we're going to use this idea on each one of these numbers inside of here. It is, because it's 1 over things. So like If you know that n squared is greater than n plus 1, you flip each side. Yeah. It's tricky. FNHC, that that'll be the next step. So, what we can say is that this is more than 1 over n squared plus 1 over n squared plus dot 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 plus 1 over n squared. And so this is great because they all have the same denominator now. Using Khan Academy to review arithmetic. Oh yeah, that's fair. These all have a common denominator now, so we can just add them up together. But we need to figure out like how many ones there are on top. Because like, yeah. And so that's the next stage of this. So the thing we started with is 1 over n plus 1 over n plus 1, 1 over n plus 2. I'm pretty sure it does work, Dojo. And so these are the things that we replaced with 1 over n squareds, but we need to figure out how many there are. Well, we're not saying 1 over n squared is greater than 1. I said 1 over n plus 1 is more than 1 over n squared. No, I don't think my school even had frats. It was pretty small. Some of, it definitely is, Dojo. I'm not sure. Oh, 1 over n squared. If you're starting from n equals 1, but that's not even the question. I'm sorry. Oh wait, did you talk about this some 1 over n squared? It's gonna be equal to 1. Brat hazing body cam? Oh god. I wouldn't want to see that. If you get max points to pass, oh, I'm sorry, Stefan. Well, that's what we're about to count, Stefan. So, I'm sorry, Dojo. So yeah, it's fun. I'm writing this because we want to count n squared minus n plus 1. I think it's just n squared minus n. For for this chunk here, it's n squared minus n. I'm pretty sure this works, Dojo. I'm not sure like how you're counting it, but I'm pretty sure this works. It's okay. I just I feel pretty strongly that this works. If you want, you can, if you see a hole in it, like, I'd like to hear it, but I don't see where you're coming from. Okay, so Stefan, I'm trying to count how many terms are in this chunk of the thing that we started with. And the way that we can do that, or at least the way that I want to do that, is think about it as, imagine if we extended the sum like to the left all the way to 1. So like 1 over 1 plus 1 over 2 plus 1 over 3. It won't be 2n plus 1 though. I'm sorry if that if that was dismissive. I didn't mean it like that. So between 1 and n squared, there's n squared many numbers, which I'm just trying not to overthink it. Just literally counting from 1 to n squared. And for the same reason, from 1 to n, there's n many numbers. So if we want to know how many numbers are in just this chunk, we can say it's n squared minus n many. And so that's why I'm saying, if when we go to add all these up, we have n squared minus n many ones in the numerator. So the numerator becomes n squared minus n over n, and then over n squared. Dojo, we still have a 1 over n from the original bit that's being added. Is Shiv, if I'm saying that right? Calc 3 problem? I can try it. Is this not what you're asking about before? Well, you asked how do I get n squared minus n on top. This is how I got it. No, it's 1 to n, and then n plus 1 to n squared. Or like, it's 1 to n squared. That's just n squared. Like, these dot dot dots are not equal. There's more terms in this one than in this one. Oh yeah, I can do that, Shiv. Just let me work through this problem. No, these terms I made up just for the sake of counting. We don't actually have these. The reason that I added these terms on is just so we can figure out how many things are here. So like that's another reason why this technique is kind of tricky. Like there's a couple of things that you have to just spot. And so I think it's worth figuring out the induction way too. But for that reason, because this is really difficult to see. But this is like the problem done, because we've started with that chunk. We've shown it's greater than n squared minus n over n squared. And that's the thing that we originally needed to show that this thing is true. So that is the entire problem done. And this is a lot shorter than our double induction way. Okay, I'm glad F and HT. Hey, Cruz. Oh, good luck with your exam. Hope it goes well. No, that's why it's not induction. It's exactly equal to for 4, not greater than. Well, we're still fine because we have the 1/4 out front here. We're still more than 1. Or wait, no, you found that one. Never mind. Sorry, I thought 1/4 came from somewhere else. That's weird. What about 3? 1/3. Well, no, it's always exactly 1, no matter what n is. The important part is that it's greater than. Hey, color cone. Thank you, thank you. So I want to answer Shiva's question too. Cruz, this question is from Stefan in chat. It's a really tricky one. Hey, Ayush, I'm good. How about you? Okay, so we spent a lot of time on this question. We can come back to it, but Shiva looks like they have a question about Lagrange multipliers, and I'd like to do that, and we can always come back to this one, but that's a mean fortune. Oh wait, no, I'm misinterpreting that. No, I mean that is a really ominous fortune. You have a test coming up. Yeah, I mean, good luck, Stefan. I hope the questions aren't as tricky as this. Shouldn't 1 over n plus 1 squared be on the last term? Oh, we weren't doing induction. So Frank Johnson in the YouTube chat found a way to do it without induction, and that's what we were going through. We were doing it with induction, and it got really complicated. Shouldn't everything go your way if you have any speed? It depends what direction you have, I guess. Hey, Arendelle. So yeah, the induction, when you do it with induction, there's like you have to do a second induction inside of that first induction, and it's annoying. Okay, so let me work on Shiva's question. Yeah, Dojo, I'm sorry. I was trying to follow along with your logic, but The chat was a little bit too busy, and I don't understand your notation still. I'm sorry that I couldn't follow along with what you were saying, but I don't want to spend the entire stream on just that one question, or at least if someone else comes with the question, I want to be able to help them out too. It doesn't start from 1 though, Cruz. It starts from 1 over n. So it's a little bit trickier than that. Oh shoot, and Roxra redeemed a Rubik's Cube. I don't know if Roxra is still here. Roxra, if you still want your Rubik's Cube, speak up. Otherwise I'll refund you. You wouldn't hear me, but constraint is with less than or equal to? Oh, okay. No worries, that might not make a difference. I gotta remember how Lagrange multipliers work. I did a problem with them recently, but I always forget. Okay. And so you asked me a calculus question. I am gonna shamelessly shill for Paul's online notes in case you have a question about calculus and I'm not around. This website is great. They provide really good explanations of everything you see in calculus, and they have a ton of example problems with solutions. So if you even need like a resource to study from, there you have it. Oh wait, is this even Lagrange multipliers? Actually, so Lagrange multipliers, like, the constraint is strict equality. Oh, okay, this one has an inequality. Oh, maybe we need to do 2 stages. Is that it? Okay. Yeah, so it's the Lagrange multipliers, but also just general optimization. So in nice Ayush. Did it involve 2 inductions? Okay, so Lagrange multipliers can help us out with the equals case, but it doesn't help us with the less than part of the problem. And so if we, I think I'm gonna start with yeah, it's good to see you too, Dr. L. And so if we want to, I'm gonna start with figuring out kind of where all the critical points of the function are, and then I'm gonna check if they're inside of this unit circle disk. And so we can find where the critical points are by taking the partial derivative in x and y and setting them equal to 0. Yeah, Frank, it depends where the minimum maximums are. We do have to do that, but that's not the entire thing, I think. So the partial of that with respect to x is 6x squared. We set that equal to 0. And then df dy, that partial is 4y cubed, set that equal to 0. So we do know that 0, 0 is a critical point. And that does lie inside of this disk, so we do need to worry about it. We don't even need to classify, like, we don't need to do any Jacobians or whatever they're called in this context. Hessians? We can just plug in 0, 0 into the function and see what value we get. So in this case, it's going to be 7. So okay, yeah, great, Sheev. The only thing we have to do is true, Leo. Ayush, yeah, I was wondering about a polar substitution. I don't know exactly how that would work, so I'd rather just do it this way, but a polar substitution is interesting. Yuck, Jacobian. 6, 7. Okay. And so the only critical point we have inside of the unit circle is at the origin. So the only other place we have to check is on the border, or like right on the boundary. Yeah, Roxor, this is like multivariable calculus that we're doing. And so to check the boundary is where we can use Lagrange multipliers. So what we do is our constraint is going to be g of x, y is equal to x squared plus y squared equals 1. And for Lagrange multipliers, we're going to set the gradient of f equal to lambda gradient g. And we get a system of equations out of this. Oh, that's true, Frank Johnson. Sounds good, Stefan. Good luck with your exam. I hope you do well. You're in doubt, what else? Like Lagrange multipliers? Because of the y cubed expected saddle point? Maybe, Dojo. Got to eat dirt in kindergarten. Oh no, this lambda isn't wavelength. This is just a generic constant. Okay, so the gradient of f is going to be well, we already found the partial with respect to x, so 6x squared for one component, and then the partial with respect to y for the other component, 4y cubed. It's equal to lambda, and then the gradient of g is 2x, 2y. And then we get a system of equations out of this, because we set... Actually, I'll do one more step. You can... Lambda is a scalar, you can multiply it into each component of this vector. 2 lambda x, 2 lambda y. And so then, if we equate the x with the x components, we get 6x squared is equal to 2 lambda x. Equate the y to the y. 4y cubed is equal to 2 lambda y, and then just solve the system of equations. I guess we want to subtract 2 lambda x over. Factor an x out. 6x minus 2 lambda equals 0. So either x equals 0 or it equals a third lambda. And then from this equation, 4y cubed minus 2 lambda y is equal to 0. Factor a y out. Minus 2 lambda equals 0. So either y equals 0 or y equals... We have a square root involved now. Root lambda over 2, I guess? Oh, right. And then as we need another piece of information to solve this, and the other piece of information is here. So we have to remember that x squared plus y squared has to equal 1. So the first like kind of candidate for a minimum is 0, 0, but that doesn't satisfy this equation, so we're not going to do that. I think we need to check every combination of x's and y's. So we have 4 different things to check. Well, it's y squared, so the plus and minus we don't care about. So 0, 0, it just that does not work. It doesn't satisfy this equation, so we throw it out. So I'm going to check instead 1/3 lambda, comma, I guess we can check comma 0. So 1/9 lambda squared is equal to 1. Plugging it into this equation. So lambda is equal to plus or minus 3, potentially. We need to check 1/3 lambda, comma, lambda over, I guess, a half lambda. See, the upper bound of an integral is not x. Yeah, chain rule is what you want to do with that. Frank, it does satisfy the less than part, but we already dealt with 0, 0 separately anyway, so we don't have to worry about it. For x equals 0, oh yeah, we're probably gonna find that out pretty soon here. But yeah, if x equals 0, we should end up with y equals 1, or minus 1. In Nylonco, I mean, Stefan left anyway. I honestly, I kind of want to abandon that question because it was getting kind of stressful. Stefan did post a thread in the Discord, though. You could put it in there if you already have something made. And you want to share. It's in homework help in this thread here. Oops, you can't see my cursor. In the homework help like forum. So. Yeah, I appreciate you working on that. So we also get 1/9 lambda squared plus 1/4 lambda squared equals 1. That's fair, Ayush. I'd rather show this like the general way, because you don't always have polar substitutions, and I assume Shiv is supposed to use, or like needs to learn about Lagrange multipliers in general. So like this is a more kind of like generally applicable way of doing it. Their least common multiple is 36, right? So we get, if I multiply each side through by 36, oh no, this isn't, ugh. Four over 36 plus 9 over 36. 13 over 36. Fraction math. Oh yeah, you have to do the gradient and polar coordinates. Yeah, I'll pass. Oh, what an ugly number this is. Um, 6 over root 13? Ew. Yeah, this number sucks. I'm sorry. Actually, I'm not sorry. Okay, there's only one more case to check, which is when x equals 0 and y is a half lambda. And so I assume we're like the y is going to come out such that it's plus or minus 1. I don't know. a fourth lambda squared equals 1. Maybe not. Oh, wait. Well, this is for lambda that we're solving for. So lambda is plus or minus 2. Oh, yeah. So y is plus or minus 1. If lambda is plus or minus 2. Okay. So we've got a whole bunch of points that we have to check now. This is a little bit of a tedious problem, to be honest. I should have been doing this earlier. For each of these cases, we should actually find the x and y coordinates. So if lambda is plus or minus 3, we should plug it in here and get plus or minus 1 comma 0. If lambda is plus or minus 6 over root 13, then x is plus or minus 2 over root 13. Y is plus or minus 3 over root 13. And then this is 0 plus or minus 1. Okay. Colorcode is saying that the gradient is different in polar coordinates. And so it'll get a little bit annoying for that step. If I'm applying chain rule, something like 3t squared plus 2t, I'm substituting t with x squared. I don't understand what... Oh. I don't immediately know the answer to that question, Dojo. I'm sorry. Vroxra. Is there like another part to the 3t squared plus 2t? Is that equal to something? That's what I'm not sure about. Doing the circle with radius 2, not 1. Yeah, it's a circle with radius 1. Oh wait, are you saying this is a problem? Here's the original thing. Deepanch, I don't know what exam it will be, but this is multivariable calculus. Is this point on the unit circle? Uh, 4 over 13 plus 9 over 13. Yeah, that's fine. Oh no, we're constrained for 1. In Rookster, I'll look at that more once we're through with this. Okay. So Shiv, we're at the very end of the problem now. The only thing that's remaining to do is to check all of these possible points in the original function. And then we'll be done. We take whichever one has the smallest value as our maximum, and whichever one has a big, or whatever words. Like this will give us our minimum and our maximum. Okay, so we need to check f of 1, 0. That'll be 9. F of minus 1, 0. Negative 2, 5. F of 0, 1. 8. F of 0, minus 1. 6. No? Wait, it's y to the 4th? Did I do... Okay. I don't know why I thought it was... Oh, it's what we ended up with a y cubed because we took the derivative. That's right. So that's also 8. And then we have to check these, I guess 4 points. Oh my god. I mean, there's going to be overlap at least. Yeah, that's why this problem gets a little bit tedious. Ayush, yes. They're supposed to lie on the disk of radius one. Oh, nice. Deep punch. This is where they should just let you use a calculator, to be honest. 8 over root 13. 13 root 13. Ugh. It's 16 over that. Uh, 81 over 169. Dude. Plus 7. What the hell? You understand it? Okay, thank God. I don't want to do that by hand. As long as you understand the technique. Thank you for releasing me from my torment. Conservation law of annoyance. Okay, Roxra, are you here? It's an integral. The lower was 0, upper was 2x. Oh. Okay, I understand what Roxra is doing now, but I'll wait until they're back. Um. Oh, you are here. Okay, so we can come back to the induction one after this, Ayush, if you have something you want to say about it. I don't know if I want to do that much work for myself on it, but this one, I think it should be a quick one. So you have this, and you're taking the derivative of it. So the way you would do this is the chain from chain rule, you have to take the derivative of that and multiply it, so it becomes a 2. And then inside, you just plug in 2x into this, and then 0, but 0 doesn't give you anything. So it becomes 3 times 2x squared plus 2 times 2x. Yeah, so you only multiply by 2. Like that. Okay. Oh, good. Nylon code. Thanks for doing that. Okay, and you did redeem a Rubik's Cube before. I'm going to do that now because I didn't get a chance to do it. And then I'll come to what Ayush is saying for the induction problem. That's bad phrasing. You have to be a really good solution for me to do that. Oops, sorry for the shaky cam. Okay, we're gonna do a quick Rubik's Cube solve because it was redeemed earlier. I'm trying to shake my camera when this is happening. Just scrambling it right now. It's a differential form of Lagrange multiplier that make it less of a pain in polar coordinates. Oh, really? Okay. F2L, it could be better. It's not bad though. There's a couple of the special cases where it's better just like memorize them, and I don't have those memorized. Other than that, I'm pretty good at it. Okay, inspection time. What's your time, Roxra? Like your best time? Oh no, I'm fucking up. I'm fucking up. Oh my god, this is a terrible solve. I just completely like blanked. Like I got hit by it with the Men in Black little like light up flashlight stick thing. Ugh, and my fingers are cold too. Terrible solve. Terrible. 12.4? Holy crap. My best time was 17. I'm pretty washed now too, though. Relative to how I used to be. That's a good emote. Color cone. You can solve a 1x1 in less than 10 seconds? That's talent there. Um... So we showed that the inequality is true for n equals 2. Now we see the inequality is true for n equals k. Right, Ayush? INFX. I don't know, but they just have a lot of tradition. F at least stands for function. T stands for time. So those two are kind of natural. The others are just kind of there, though. I don't know. For X, you can blame Descartes. D, I think, is Leibniz. I and N, I don't know. I guess I is integer. And N is natural number. Sounds good, Frank. Thanks so much for the help. And you know, if you're in math streams in general, I do have a friend who streams math on YouTube also. Actual education. The second person will be on that list. In case you're interested in streams like this. X goes back to Arabic? Oh, maybe. Yeah, you should. It sounds like we started with the same way. Yeah, Frank. Hope you have a good day. And E. Oh yeah, I mean that's in honor of Euler. Okay. So yeah, I think so far we've done the same thing here. I'm quickly looking at. Well, okay. 1 over n plus 1 over n plus 1. Right. I'm also quickly looking through nylon codes to see if it's different. Oh, interesting. Yeah, this is a different approach. Oh, this is like a. That's a cool way to argue it. It's almost more like a calculus argument, but I don't think you actually like take a derivative. Yeah, that's a neat way of thinking about it. Proving it's monotonically increasing. Hey, Enochian, hope you're doing well. Math gaming. No, I was talking about a solution that Nylonco posted in the Discord, not yours. Um, I should have actually shown it on the screen, I guess. But Nylonco is looking at the difference between consecutive like values of n and showing that it's always positive. That contradiction. And so if it's always increasing, as long as the first one is more than one, all the subsequent ones have to be more than one also. Thank you. In Enochian, actually, I cut my own hair, and I messed it up a bit because it was my second time, but um, not that badly. Another contradiction that algebra made sense in my own head. Yeah. Do you cut your own hair, Enochian? Okay. I think there's a little break here where there aren't questions from chat. So if someone has something they want to hit me with, let me know. Um. Oh, nice. Otherwise, I might go back to doing homework stuff. I mean, if you have something you want to say about them, FNHC, we can come back, but I don't have anything else to say for myself. I need to clean off my glasses. 1 second. Okay. Fiber bundles. I do not. Did the music stop or is it just quiet? It stopped. I've had people in chat talk about fiber bundles. I don't know about them for myself though. Oops, that's not what I wanted to do. Unfortunately. Someone else in chat sees that message and knows about them. They might speak up. Unfortunately, I can't really say anything about them though, or I don't know anything about them. Oh hey, Colorcom might know. Okay. So this homework question I was working on before we were doing the induction and Lagrange multiplier stuff was about a predator-prey model. And I'm on the very end of the question involving drawing a phase portrait for this system. We do a change of variables just to get rid of some of the parameters because there's a bajillion of them. And I think I was trying to figure out around one of the equilibrium points, around 1, 0, how the phase portrait around there should look. Oh yeah, and so I was confused. by an eigenvector that's like this. Is this a vertical or horizontal eigenvector? That's what I was confused on. I feel like this should be obvious to me, but for whatever reason it's not. It's a vector of the form x0. Oh, is this horizontal? I think that's I might have messed something else up in a previous question if that's the case. I might have made the same mistake here. I need to go back through my work. I think I did make the same mistake. Ugh. I don't want to redo that one. That one's a huge pain to redo. Your general relativity and Yang-Mills theory are fiber bundles. Huh. I think I've had them described to me, and I still don't know what they are, really. Oops, scroll down too far. Oh, well, thank you for the kind words, the punch. I appreciate that. Okay, so I think the saddle point is actually going to look like this. What's up, Roxra? Okie dokie. Hello, hello. Wait, so what does this mean, like, biologically? If f of x is position, f prime x is velocity, f double prime. Oh, it has a name. I can never keep it straight. There's a Wikipedia page for this, though. Fourth, fifth, and sixth derivatives of position. They're called, oh, it's jerk. And then the fourth derivative is snap or apparently jounce. And then crackle and pop. So, I don't know if you ever really have to use these. That's a good question. Jerk with everything? That's true. Or acceleration. I guess you could think of it as like the fourth derivative is the rate of change of acceleration? So velocity is the rate of change of position. Acceleration is the rate of change of velocity. Jerk is the rate of change of acceleration. So you would have non-zero jerk if your acceleration is changing. So if you're in a car and you're like pressing on the gas pedal more or less, then your jerk is non-zero, which sounds weird to say. I think. It definitely, like, the more derivatives you take, the harder it gets to interpret. And yeah. That's a nice way of thinking about it, Dr. L. But for physics, this second derivative is the important one. Yeah, color cone. I guess they're named after the Rice Krispie elves. Hey, Dessen. It's gonna sound strange. I think I saw your doppelganger the other day when I was walking. Really? Do you see Ed Sheeran? Are you? I was going on with the induction problem. Stop jerking us around. I'm like 5'11". You sure the rest of the part is more than 0 as well? Here we do one thing. 1 over k equals 2k over 2k squared. 1 over 2k squared plus 1 over 2k squared. Oh, the 4'8" version of me? That's funny. Mini me? Your sort of idea isn't a good one. How hard you press an accelerator doesn't directly impact force in a car. For actuators and servos, there's a more direct correlation. Okay. Fair enough. I was just thinking of, like, gravity has a constant acceleration, so jerk is 0. And so I was trying to think of a different situation where our acceleration is changing. I guess with air resistance, maybe you would have jerk. Yeah, Rex. Jerk. That's true. Okie dokie. Number of terms of estimation are 2k plus 1. 2k. Uh... Maybe. I'm sure you mean with clubbed. I'm doing Calc 1. Now, what does Calc 2 explore? Is it realistic? Oh, I mean, absolutely, it's realistic for you to go into Calc 2, Rogstra. What Calc 2 typically covers is more difficult integrals. And, like, the techniques you use to like tackle those, like integration by parts is a great one. Sometimes they really grill you on the applications. Yeah, I mean, definitely go for integration by parts. And Zach, thank you so much for the raid. How's your stream? I was peeking at it a bit. Ivan, hey, welcome in. Hope you're doing well. We've been talking about a lot of stuff here. We're just talking about the fourth, fifth, and sixth derivatives of position, which are called jerk, snap, or jounce, which is much more fun. Crackle and pop. I was trying to think of an example of, like, when at least jerk would matter. The higher ones are even harder to think of, but yeah. And then Roxor is asking about, like, what to study next, because they've been learning calculus. That song was pretty good, Dr. L. Just changed now, but whatever one was before it. Acceleration feels like a constant force. shifting gears. Oh, interesting. Okay. "15-year-old self shifting gears in a car gave a real sense of jerk." um. So yeah, Rooks are like, integration by parts would be a great thing. That like is firmly like a Calc 2 thing, but like it's not that bad, and it's pretty cool. The other thing that Calc 2 covers is like different types of coordinates and doing calculus with those. And then the other major thing are series and sequences, which are kind of like a little bit different from the rest of calculus, but really important and good to know. So these will be a bit of an adjustment, but series are absolutely like a great thing that you should start learning too. That's once you get through the earlier stuff. If I were Einstein, what should I learn next? Oh God. I don't know. Einstein would I feel like he's gonna be inventing the thing to learn next. I think so, obtuse baboon. Obtuse baboon babu. That's what Wikipedia says. I mean, you're just doing this for like self-study work, so I'd say like keep on going with Calc 1 until you're bored of it, and then just go to Calc 2. Like you're just do whatever it takes to keep yourself interested, I guess. It doesn't sound like you have a specific goal with this. You're just learning it because you enjoy it. So I say just kind of go where your gut takes you. Oh, I might see what you're saying now, Ayush. Um, yeah, that it's a little bit of a difficult part in there in the last equality I'm still thinking about. I think it's similar to an idea someone else was putting in chat before. I don't remember though. How fast you can find the serial from this Wikipedia? That's a great question. It's probably it's only one. It's only one layer of Wikipedia page. That wasn't okay. Never mind. That is a good question though. Okie dokie. It's a fun game. Materials are using. Oh yeah, about the fiber bundles and general relativity. Christoffel symbol touched you. Christoffel symbols. Sounds good. Roxra. Thanks for the hell. Have a good day, Roxra. I'm always happy to give people hell. There's a whole song about that, even. Okay. I guess unless there's gonna be another question from chat, I'll go back again to doing homework stoof. Actually, I probably shouldn't be streaming for that much longer because I'm gonna need to really get a lot of homework done. But the real math problem is why I have to charge my water. You have to charge your water bottle? Are you serious? Supposed to into the math coffin? Yeah, that's kind of one of the last things that I learned when I was trying to learn general relativity. That's when it was getting really difficult. I remember you shared a video about them though, and that did help, but they're still really out there. Does it have a light on it, or like why would you possibly charge your water bottle? Okay, so this question is for my math biology class. We've been talking, or at least we moved on now to like epidemiology, but this question is about like predator-prey equations, and this one's a pretty cool example of one where predators grow logistically, but the carrying capacity is variable. It depends on the number of prey, which I think is kind of a cool modification. I was on the very final part of this question about drawing a phase portrait, and I was trying to figure out what the behavior looks like around each of the equilibrium points. You have aphantasia, out of sight, out of mind. Oh, you can't like picture things, yeah. Reminds you to drink water. It does have a light. Interesting. I didn't realize that people with aphantasia would have that problem, but that's cool. It's almost like an alarm clock, but for hydration. If Color Cone goes live, I will raid him. I'm not going to stream for that much longer. Notification on your phone too? Oh, wow, that's cool. I would like to figure out this phase portrait, though, at the very least. Okay, so around there's an equilibrium point at 1. Oh, yeah, I wanted to figure out 1, 0 as an equilibrium. What does that correspond to? Or like, what is... I'm worried about this eigenvector here. So if we have 0 predators and some amount of prey, no, should it be a vertical line? Because if predators are 0, prey should be growing. Oh, but to a carrying capacity. That does make sense. Okay. Maybe for the other one, maybe I did it right. Still. Because I had a similar situation with this equilibrium point. And I'm worried I did that wrong, but maybe because it's a different equation. If we have 0 plants and any amount of herbivores, they would go to... No, I think I did that wrong. Ugh, never mind. Like I'm in a Twitch chat IRL, someone hit the hydrate channel redeem. Oh, true. I don't have that one turned on my channel, but I've seen that in other people's. Today I learned that women over 40 who have in vitro fertilization are far more likely to conceive with a much younger man because young sperm corrects their old eggs. Really? For men choosing young trophy wives. Huh. That's an interesting fact, Dojo. I wonder if there's some, like, I assume, like, by corrects it's something with, like, the DNA, like, replication that it does better. His differential equations to get a date, never mind to marry. They're actually, let me see if I can find it. There's, I don't know if I have the book as a PDF. I hope I do. Strogatzis. Yes, I do have it. This book has a really funny example that's kind of like what you're saying, Dojo. This is Steven Strogatz's nonlinear dynamics book. I want to actually read this thing through properly at some point in my life. I've only skimmed it. But he has this example of differential equations with Romeo and Juliet, and I think it's a really funny example to use for differential equations. So, you know, in a way, maybe you can use differential equations to get a date. Well, comedy is tragedy plus time, Raven. It's been hundreds of years. Yeah, so like R of t is a function measuring love or hate. Same with J, but yeah. Yeah, the dynamics of a relation, exactly. He streamed on YouTube? Wait. Dude, I'm gonna look up on YouTube right now. Steven Strogatz. He does have a channel. 10K subs. Huh. I don't know he makes math videos. Or it made, I guess. I don't see any, like... streams, though. Maybe those didn't get saved. I don't know. Yeah, so... Thank you, Raven. Yeah, no, Strogatz is awesome. But before I knew he was a big deal, I applied to uh be a PhD student at Cornell, where he's a professor, and I put him as my like #1 person that I'd want to work with. And if I knew that there was basically zero chance of that happening, I probably would have like I mean, I probably still would have said it, but I would have said it differently. Okay, so I think that's how the behavior is going to be around the 1-0 equilibrium. You just kind of fill in the blanks based off these eigenvectors. Now we have this other equilibrium to deal with. And I think I said it's in applications are probably going to be a stable node, more likely than a stable focus, and those are easier to draw. Shooting for the stars? I guess so, yeah. Okay. So I think our phase portrait is going to be something like this. So this equilibrium up here is going to be a sink. This one is going to be a saddle point. If I add variables, I can use differential equations to date more than one girl. Have 100 differential equations. It's a genius idea. Used text for nonlinear dynamics when I was in college. I mean, yeah, it's probably his or that might have been the exact text we used, the one that I just showed. I never actually have taken a class in that, and it's I think if I actually did study it and learn more about it, it'd be like one of my favorite things in math. Because I already like dynamical systems a lot. It's a great one, Leo. It's just all about this node here. I don't know if this arrow is quite accurate. It depends on the strength of the node, I guess. Cornell Library is very impressive. Oh, really? Oh yeah, Dojo. I'm not doing that right now, but I definitely have some IOUs in my head for textbooks I'm going to actually buy once I graduate and get a job. Some textbooks I don't care about at all if it comes from like a publisher that like is just like wringing money out of students, but other ones that I either really like or aren't like that, yeah. Um, I guess that's my phase portrait. It feels like it's missing something, but I might just leave it like that. I do need to go back and fix my phase portraits from number 1. Because I realized I got... Wait, did I get this wrong? I think what I did wrong is that this vertical line should be a horizontal line. But that doesn't make any sense biologically, either. If there's 0 herbivores... Wait, does Leo stream? I thought he said he streams like barely ever, but he does make videos. Wait, so what's happening in the phi over a comma 0? If there's 0 herbivores, shouldn't... I think it should be unstable. And horizontal. Getting conflicting information about how often Leo streams. Did one test stream where a friend asked about dynamic programming, which is fire. I don't know what dynamic programming actually is. At least one. Yeah, it's true. You could both be lying. It's a good point. Um, the group theory stream and the logic stream where I was just lost. You can define the elliptic curve group law using the Picard. I don't know what either of those things are, so I did not know that. Oh, you're talking about what they're... Never mind. Talking about the conversation between color code and Destin that I've been ignoring, so I don't know what they're talking about. Free Picard group. Um. Yeah, I mean that's the magic of having the shared chat up there. So when lambda equals minus a, that becomes 0. The eigenvector x can be anything, y must be 0, and so that's the thing that I got flipped. I think, okay, so let's just, I'm kind of done thinking about this. I'm just gonna make this change. It doesn't quite make sense in my head, but I think it's what the math is saying, so let's not question it too much. Now I have to update all three of these things here, annoyingly. And you know what? I am going to take a screenshot of this. Actually, no, I should do better than a screenshot. I should do a copy paste. Here we go. Much better. I'm updating some phase portraits that I drew in a previous problem that are no longer, or that I realized they're not even all that wrong. I'm probably putting more effort into this than I really should be. But I realized that I got the eigenvector going, one of the eigenvectors going the wrong way. And I just want to correct that. What I guess you this is like dynamical systems, I guess, or mathematical biology. It's like that. And the other one is going outwards with a positive slope. Like that. This one goes like that. And outward like that. Okay. There we go. So this one's fixed. Should have gone to dynamical systems too. Every single math professor in dynamical systems is super open for questions. In fact, demanded questions. Ooh. It's always so awkward though when the professor like pauses, like asks a question to the class and pauses, and then like no one answers it. And like it becomes like a game of chicken. I had the opportunity to take dynamical systems with this semester, picked number theory, and they were clashing. Fair enough. I personally would definitely choose dynamical systems, but number theory is a good thing to know too, depending on your interest. A bunch of early nonlinear dynamics was trying to figure out vacuum tubes. Really? I did not know that. Okay. I think those are my phase portraits now. Number three dynamical system war still rages on. Yeah. Many lives have been lost. Skimming through the textbook, might have to play around with those problem sets. It seems like such a cool book. Tori, I think Tori is the plural of Taurus. I don't know what it would mean in. Or wait, algebraic Tori. I don't know. Probably something weird. Okay, so I think that's good for this homework. I'm gonna need to LaTeX this up, but that'll be off stream. We're at 2.5 hours. I'm debating what I want to do here. It is the plural of Taurus? Okay. Um, I think I'll keep it going for a little bit longer. I do want to turn the stream off just so I can completely focus on homework. But I don't want to do it quite yet. I am going to switch to a different homework assignment though. If your jounce is positive, it means you're being more of a jerk over time. That's very true, FNHC. In algebraic Tori, it's like a Karen that just spouts algebra at you. We also refer to elliptic curves as tori, since over the complex numbers, as Caller said, they are literally tori like you'd think of it. In algebraic sense, elliptic curves in general have genus 1. Is an elliptic curve... Well, what is an elliptic curve? Genus? Like... Oh. Okay. It's a new one. I think of genus as like the biology thing. Should put that on a shirt? Yeah. The thing you have on the canned drink? Oh, yeah, like the little tab? It does look like that. I don't know what an algebraic curve is. You know, should I care? I feel like I shouldn't care. If you squint really hard, you can see the connection with the elliptic integral, and if you squint hard, you can see elliptic integral has something to do with an ellipse. Okay, I was wondering if there was a connection with, because that's where my mind went with elliptic integrals. You thought of, you know, Slim? That's a good idea. And the place can be called Genus Donuts, and people would think that the place is called Genius Donuts, but then I can be really arrogant and correct them and say it's genus. Kevin Cuomo and Alan Oppenheim. There's a new approach to this problem of synchronized chaos. You transmit the message to your friend, you mask it, the much louder chaos, and outside listener only hears the chaos, which sounds like meaningless noise. Ooh. That's like a way of encrypting something. That's pretty cool. Hey, singular moduli. Yeah, I have this Wikipedia page open. I can't claim I understand it, but I was just curious what this is, and I'm no closer to understanding it, but I have it open. I play this affine space, affine and spacey. I'm not even there, so. Quite a bit of cryptography is built on working over elliptic curves over finite fields. Oh, interesting. They're like integrals of the form. Yeah, because I made the mistake of trying to get the arc length of an ellipse before, and I ended up with something terrible. And I was like, how do you ever compute this integral? And then I realized that's a whole area of study. That's like its own field. So I had this knot theory pseudo test earlier today. Had to find a genus. Really? I didn't know that you're doing knot theory. That looks crazy, Peach Tea. Or like, for what I've seen of knot theory, it's kind of crazy. Comes back for elliptic curves. It's called elliptic takes. Okay. It's an application of analog computers too, something I'm super interested in. Ooh. I guess singular module. I don't have a specific question. It was just trying to follow along with what Destin and Colorcone were talking about, but I should really know better than to try to do that by now. Don't understand. I've been trying to get it for 5 years. It's like an elective, isn't too rigorous. Oh, good. Degree 3 curve in a plane, plus a point of infinity. Among other things means if I put 2 points on the elliptic curve, one more point on the curve. Wait, if I pick 2 points on the elliptic curve, do one more point through the curve, which points. Oh, okay. You can define the group law. Oh, okay. Elliptic tails. Okay. Okay, where was I at with this homework assignment? Okay, number 1 definitely needs work. What about number 2? I think number 2 is fine. Number 3, I think is fine. Okay, yeah, no, and I think number 4 is fine too, which is good news, because I really need to have this done, ideally by today. It's not due until Friday, but I need time to work on a different homework assignment that's due on Monday. And this thing is standing in the way of that. Yeah, so the only thing I have left to do for this is number 1. And for number 1, this is the hypergeometric, or it's like the differential equation that I guess you can use to define the hypergeometric function, or is somehow related to it. And we have to get an asymptotic expansion for it about each of the singularities. And so if you do a certain change of variables, you get poles at 0, 1, and infinity. Making series of streams about it? Ooh, cool. Um, the chaos math experiment was not really expected to work. They tried it anyway, and it worked kinda. That's the kind of math I love. I mean, if you know exactly how the noise... I guess if you know the exact state of the noise at any time, I wouldn't know why it wouldn't work. But maybe they're talking about like generating the same noise, not just storing the entire bit of noise. Oh. Oh. Um, there's something about like the very end of this problem that I'm just like not quite sure about. I'm trying to put it into words right now. So in do stuff with that hypergeometric equation, there's an amazing paper about monster group. For each conjugacy class, there's a unique equation. Oh, yeah. So I was reading the Wikipedia page for it, and they mentioned that it has a connection with like groups. Um, to the Coxeter group, which I don't know if that's related to the monster group that you're talking about. Yeah, I feel pretty comfortable with little o notation now and big O. It's still a little bit weird, but thankfully they're not like grilling us about it now. We just kind of get to like use it and they don't question us too much about it. Yeah, I never been much of someone who knows about or particularly likes like algebra or group theory, but I don't know. Maybe I just haven't seen the right application for it. Back in 2010s, an in-teaching a student discovered a group structure on the circle. They published it on the Australian Gazette. Try to get over my expensive preference for physics textbooks over PDFs. I am using Journal++, yes. Um, I don't know, Frank. I don't. I do like the feel of a physical book, but they do take up a lot of room and they're expensive, as you say. I don't know. You just kind of have to start to use a PDF. I don't know if there's really anything else you can do besides just doing it. um, it's always the dream just to have like a library worth of like books and stuff, but it's just not like realistic. I don't know. Hurts my heart to hear. Yeah, I'm sorry. Singular module. I've had like attempts to learn abstract algebra and group theory, and I have a very hard time getting into it. Um, I really prefer applied math to pure math, and if I don't see the use for something, I just have a hard time getting interested in it. And so I might be able to like get interested in group theory if I learn about it through an application, but just studying it for its own sake is just like I'm gonna get bored, I guess. Group theory how useful quantum mechanics and classical mechanics. Fair enough. It also comes to geometry, applied math, yeah. And Raven, yeah, there's no music on YouTube. These are almost only PDFs. I've been thinking of trying to get more physical books lately. Yeah, I want some books as physical books just because I like them so much. Group theory applied to geometry, crystal physics, things like that. Ooh, cool. So they say no percent on their own. So you think it's abstract. Foundation of CS and physics, linear algebra applications are endless. Yeah, I mean, I haven't seen a single application, so that's why it's hard for me to get behind it, I guess. Probability theory counts as applied math. It's definitely a lot more applied than other places in math. I guess the thing I was stuck on with the problem is there's all these different cases depending on the value of C, or like what set C is in. And this Wikipedia page tells me what the answer should be, but I'm trying to get that answer out of my work, and it's not like... it's hard to like think about. Oh, I mean, done. I have a Rubik's Cube right here on my desk that I like fiddle with whenever I'm bored. I do remember, I am a group. I don't just know group theory. I am a group. Because Penn Center, a long time ago, was doing a reading group for abstract algebra, and I was trying to follow along with it, and I was for a long time. It's also like the one time I've tried to learn abstract algebra. And I remember in the book we were using, they do talk about the Rubik's Cube being like basically forming a group. Probability theory is pretty much at the same level of abstraction than graduate level functional analysis. Yeah, I mean, probability, like, it's inherently applied, but you can, it's also like, they usually just talk about it in a theoretical sense. I don't know. Can you handle silo theorems, or is it CELO? I feel like I've heard Zach say CELO, like the singer. Can we go through random actions? Solve or prove theorems is still tough. Fair enough. From symmetry to things. Yeah, and then like, because I remember learning about the dihedral groups, and I'm like, this is so stupid. I don't care about this. Like, and I'm sure that's sacrilegious to say that it's stupid, but like, I just can't get into it. Oops, sorry, I just tapped my mic. So it's this thing here that I need to worry about being an integer or not. Dihedral hidden subgroup problem is the only thing defending cryptography from quantum computers at the moment. Oh, I think you've mentioned that. I don't think I've heard of, or I don't think I know what it is, but I remember just learning generally about like dihedral groups. It is, yeah, it's for stupid, dumb dummies. Exactly. It's exactly how I feel about it. The entire value of elliptic curves is that they are abelian groups over finite fields. Fair enough. You have to learn group actions, probably the deepest definition in all of undergraduate math. Okay. Squidward emotes are so good, color cone. Grand mechanics professor set up a vibrations problem with 3 springs equally spaced on a circle. Oh, what the hell? The setup resulted in a gnarly 3x3 matrix. Using the group of 120-degree rotations, able to block, diagonalize the matrix into a 2x2 into 1x1, which was trivial to diagonalize. It was a mic drop moment. Huh. That, you know, that sounds cool, Dr. L. About that. What the? I need to zoom and enhance. Oh my god, that is a thick Mr. Krabs. It's a great emote. Doesn't care about getting rich. Ugh. I wish applied math was good at getting you rich without having to get into AI. Um, so I think the pointer is if C is an integer, eventually where there's going to be an issue with one of these running into the other. And when that happens, I still don't completely understand what how you deal with that situation when it does happen. So I'm pretty much worried about like from the start of this paragraph here. This Q sub m thing is the thing that I'm really kind of confused by. No collab project we can do on stream about bag of words, but all the different words that like algebraists use. I'm learning a lot of definitions myself, and schools are still trash. Mrs. Amy Lay stumbled on this way over your head. Welcome in. I mean, it's brave of you to even type something. Most people, when they see a math stream, just like run away. Yeah, so like my background is I'm a graduate student. I'm going for a master's in applied math. And so if no one in chat has a question to ask me, then I'll do homework, and so we get crazy looking math like this. But if someone asks me a question like even like how do you multiply for fractions or like add two numbers, I will happily like talk about that too. But a lot of people who look at math streams on Twitch tend to want to talk about like more advanced math that makes people feel stupid, and this math makes me feel stupid right now too. And so yeah, I'd love for the stream to not just be about like ridiculous looking math and be more accessible, but it's kind of hard to like do that. So yeah, I'm sorry. I definitely don't want to make you feel dumb, but yeah. Thanks for being here anyway, though. There's a whole little niche of us who stream math on Twitch, and so we all have our own like kind of like angles, I guess. And I'll say like e to a pi does have specific days where he like it's like specifically like no high level math allowed, pretty much. And I really appreciate that he's been doing streams like that. It's a model of word embedding where a neural network learns the semantics of words. Oh, interesting. Color cone. I'm going to be getting into neural networks soon. Don and Zach learning all the fancy algebra terminology. Got an stream on YouTube the other day. Oh, what's their name? Peach Tea. Part of the reason why I like algebra is because of the poetic words compared to analysis. Most theorems are names of people. Oh, funny. Kind of like the human name theorems. I mean, I think it's fun. What the human name theorems feels kind of vain to me, where like people, once you start naming theorems after people, people like start pursuing having a theorem named after them, and that just feels, I don't know, like kind of wrong, or I don't know, it's vain, I guess. So I kind of like it when theorems have a fun name. The key to sound smart, have a niche. Yeah, that does help. Yeah, so if someone does ask me like a question, no matter how basic it is, I'm always happy to talk about that. But when there isn't a question, things get complicated again. Sorry, I'm behind on YouTube chat. YouTube keeps eating my comments. You're missing great jokes. I'm sorry, Leo. Both you and Frank hate using Twitch. That's fair. Like, Twitch isn't perfect. I prefer Twitch personally, but it does have its issues. Not knowing what something is doesn't mean you're stupid. Just means you don't know the thing. Math is quite a language. Yeah, there it is. Our mathematicians communicate with each other a lot of the time. True. People speak only within terms and can't elaborate. I usually think they aren't very smart. Yes. Or at least, if they are smart, they can't prove it. Even worse with Lie algebra, whole subject named after a person. I love the subject too. Ooh, fair enough. Sometimes they're not even the first person to find it. That too, yeah. Math is quite easy in bag of words. You can probably show that to good multivariate calculus students. Okay. Lie theory is a cool name. I mean, especially if you don't know how it's pronounced, at least, because it's like the theory of lying is how it sounds. Or if you don't know it's named after a person. If your name's cool, you can have things named after you. Yeah. The committee of cool names shall decide who has a cool name. Dr. Zai. Okay. I'm always interested to hear if someone is doing a stream like this. Dr. Zai. So it's always good to like. Oh, 168k subs? Ooh. Only just recently started streaming, it looks like? How does it... Does he delete his old videos or something? How does he have so many subs and 13 videos? Huh. Either way, could be interesting. Thank you for sharing, Peach Tea. Not sorts that I can't solve things like I'm supposed to be able to. I mean, I feel that way a lot, especially with this class test when I'm talking analysis. Like, I feel like I can follow the lecture, but when it comes time to actually solve a problem, I just get completely lost. I remember I found the right order of math streamers here so I can ignore the big math channel / discords. I think you have singular moduli. Like, this is the list of people who I generally, like, recommend, and I think I've seen you in, like, a fair amount of these chats, or you've been like making the rounds. Not everyone on this list is like particularly active still, or they have their phases of being active or not active. But yeah, like generally like just the math category on Twitch and then searching math in the search bar on Twitch are, and you'll basically find us. Will I ever go to YouTube and dual stream with Leo? I mean, I guess it depends on like what it's about, but I'm not opposed. You killed the first part of my joke. All right, see you, Leo. I think it's determined animal systems in the phase space where once you get in, you can't escape. I feel it's like a sink or a uh there's another word for it, but like a sink versus a source. Yeah, I much prefer Twitch too. Oh yes, singular moduli. Like one thing I really love about the math community on Twitch is that like when we find a new person, we're good at like bringing them into the fold, I guess, for lack of a better word, like into like the network of like, I guess like association or like friendship or whatever. I don't know that I don't have a good word for it, but like through just like raids and popping into their chat and sharing links around whenever someone new comes up, the word spreads. Snazzy. An electron moves at that speed through uniform. Ooh. I do love me some E and M. Shoot, it should probably be the last question today. Because I did mean to turn the stream off at some point soon. But E&M is pretty awesome. Okay. Sounds good, Singular Moduli. Thanks for hanging out. Finally getting to maximum in my calc-based physics 2 class. Noish. All right, so what's the formula for the Lorentz force again? Do I remember this off the top of my head? It's like, we don't have an electric field. So we only care about QV cross B? I should verify this. I think that's what it is. Yes? Okay. Thank you. You need for about half a year. Only now do I need a calculator for exam? That's annoying that you even need one at all, but fair enough. Q is magnitude. Oh. Okay. Carla Professor will be one of the winners of the Fields Medal this year? Wow. That's crazy. Oh, for stats. That makes sense. A four-wheeled adventure will soon bring you happiness. Ooh, that's a fun fortune. This is such a weird way to give the direction of velocity. What's happening here? Velocity electron lies in the xy plane is directed at 40 degrees to the plus x-axis. Oh, it's the same measurement expressed two different ways? Is that what they're saying? Like they're just saying this one down here is 40 and this one up here is 50? That's a very weird, but we can do it. (2.20 times 10 to the 5 ms). It might need to be the sign charge. I didn't learn it with the magnitude, but maybe we fix the direction at the end anyway. The way that I learned it is without the magnitude, but Snazzy said with magnitude. We can always think about what direction it should go and just make sure that it matches. Oh, VB sine theta. So you even go a step further. That's fine. And actually, if you do it with the sine theta, that might be why. We usually state our known and unknown so we can set up our formulas. Oh yeah, that's a good... Like... That's a popular way of... like, teaching problem solving in physics. Magnetic field points in the plus y direction. And it's uniform. It's 1.35 Teslas. Okay, so that means the angle we care about is the one with the y-axis. Right? Yes. Yeah, yeah. You mean 40 and 50? Oh, okay. Yeah, Frank, I've had people say that on YouTube before, that their stream gets delayed. I don't know why. Sorry about that. Revising prior year's exams, is doing one on paper. No, it cannot commute the inverse square root of 200 times 0.2 times 1 minus 0.12. Looks like a standard deviation. Come on, syntax, that's mental math, right? Okay, so do we just have everything that we need immediately? Q is this charge in coulombs. Okay, yeah. I mean, we should pay attention to the direction here, but I think it should just be plug and chug. Sine of 50. So whatever that comes out to, it's going to be a positive number. And we can use the right hand rule to make sure to figure out what direction the force is going to go. So you point your fingers in the direction of the velocity, curl them in the direction of the magnetic field. So the right hand rule, I think, says it's going to be coming out of the page towards us in the positive z direction. So this thing being a positive number is a good thing. I guess we should say, oh, they only asked about the magnitude. Oh, the magnitude of the, okay. They're only asking for the magnitude, so we don't even have to care about the sign. Never mind. So yeah, if it would help you, I can plug this into a calculator and get an actual number, Snazzy, but like, is this what you wanted to see? Do you have a specific question about this? Advised to attend seminars and walk like a brainless chicken. Eventually I will pick up things. It's a hell of an expression, but okay. Oh, okay. Sounds good, Snazzy. Fair enough. I do love E&M, even if this one was just a direct plugging into a formula. I see. So yeah, since they asked for the magnitude, what we actually did is we took the magnitude of this, and the magnitude of the cross product is VB sine theta. Okay. I think technically you need like these two, but who cares? Thank you for the question. I do think it's time for me to wrap up the stream now, though. Yeah. So thank you everyone for being here. I'm gonna cut the YouTube stream off here, and on Twitch we'll look for a raid. So Leo's already left. Frank, thank you for being here. Anyone else who's here on YouTube? Can I do a rap? No, I can't do a rap. See you later, YouTube.